Okay, so for our final two questions, and I think I'll do them both together. Um, this was one of the big ideas this chapter is that we can look at an area model with algebra tiles, and we can look at what's called a generic area model, and we can use it to multiply binomials. And this is kind of important because there's some misconceptions about things that happen. So, for example, in class we've seen problems with if you were asked to, for example, multiply 2x plus 3 times x plus 5. Initially, some of you were saying that would be, 2x squared plus 15, and that's really missing part of the answer, right? There's things that the area model reveals that we missed. And another thing that we've observed is this: if I had, for example, like x plus 6, and you were asked to square that, some of you would say that answer is x squared plus 36, but the problem with that answer is that it's missing some important parts of that product, right? It's something times itself. So the reason why we look at these area models with algebra tiles and generic area models is so that we really understand what's going on here. So the first thing is it says express the area of the rectangle below as both a product of its dimensions. So a rectangle has a length, a rectangle has a width, and we're just going to show length times width. That is one way to express the area. Now if I look at this, I guess I'll call this the width along the top here. This tile is exactly x units long. This is x units long. This is a single unit, and this is a single unit. And remember, some of you looked at these and you decided they were x squared long, but this x squared is the area. So when I multiply this x times the x above, that's how I get these areas of x squared. So if that's the width, x plus 1 plus 1, this is the length, x plus x plus x plus a 1 plus a 1. Now we would simplify that. So here I'm going to write the product as the product of its dimensions. So this is length times width. So I'm going to write this as 2x plus 2, and that's this dimension from along the top, right? You can see there's two x's and then plus a 1 plus a 2. So I'm literally adding these things together, right? I've got a length of x plus another length of x, that's 2x, plus a length of 1 plus another length of 1. So that's the 2x plus 1. And then the other one is 3x plus 2. So I'll write times 3x plus 2. Now, when I get the answer to that, right, if I was to multiply that with a generic area model, it's the same answer that I'm going to get here from the algebra tiles. You can see that there is exactly 1, 2, 3, 4, 5, 6 of the x squared. So as the sum of the parts, there are 6 of the x squared tiles up above. And if I was to count the x tiles, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10, so plus 10 of the x tiles. And then there's 4 of these little unit tiles, right? 1, 2, 3, 4. So I would say plus 4. So this is the two ways that we can write the area, right? Length times width, it equals the sum of the parts. And they are equal to each other, right? The thing that I've written up above, the product of its dimensions, is equal to the sum of the parts. So that's one problem using algebra tiles, right? And on number 12, it says multiply the polynomial below. Simplify your answer by combining like terms. You may wish to use a generic area model. So on this one, I can see the first part of this problem has 1, 2, 3 things, right? There's 3 terms in this first factor, and then there's 2 terms in the second factor. So the model that I'm going to build, I'm going to go ahead and build it this way. I'll just go 1, 2, and you don't need to be anywhere near. This is kind of ridiculous that I'm doing this. And I'll just go along here. 1, 1, 2, and 3. And it was not very clean. Let me grab my eraser. In fact, let me get the small eraser so I can clean up parts of these. There we go. So I need to sketch this more quickly next time because this is totally an inappropriate waste of your time and my time. So down this one side here, I'm going to go ahead and write this is an x squared, a negative 2x, and a positive 2. So that's just x squared, negative 2x plus 2. That's one of the dimensions, times, down here I'm going to write 3x and then plus a 1. And you can see the 3x and then plus the 1. So every single one of these little tiny rectangles in this generic area model has its own area, and I just get that by multiplying its two dimensions. So for example, simplest case, right, is when I multiply this 2 times this 1, I get the value that goes right here, and 2 times 1 is exactly equal to 2. So we'll start out with an answer of 2 there. The next part, I can multiply the 3x below times 2 and get that this is equal to 6 times x. I can also multiply the 3x times negative 2x and get that this is negative 6 x squared. And then below that I can multiply x squared times 3x and get that that's 3x to the third power. And then I'll go over to the right. X squared times 1 gives me this is x squared. And then right above that I've got negative 2x times 1, which gives me negative 2 and then x. There are some things that we can combine here. They're like terms. So for example, this 6 times x, I could combine with the negative 2x. They're like terms. They're both just a coefficient with the variable x. And then I also have these squared terms, right? I've got the negative 6 times x squared, and I've got just the x squared by itself. So the simplified product that I would write down below here is this contains 3x to the third power, and then looking at the green part, plus, actually it's negative, isn't it? Minus, that is negative 6x squared plus 1x squared would be negative 5x squared. And then you can see for the yellow I've got 6 of the x's and then minus 2 x's, which would give me plus 4x. And then the last thing that I have there in that product is the number 2. So plus 2. So this is the simplified product, right? And you can see this up above is me writing down the area as the product of length times width, right? Product of length times width. And that equals, right down here, the simplified sum of the parts. So that is it for this test.